What if all solar energy was focused at a single point? Every second, the sun pours out more energy than humanity has used in its entire history. It lights up our skies, powers our climate, fuels life on Earth. And yet, what we receive is just a tiny fraction of its total output. Now here's the wild question. What if all of the sun's energy was focused onto a single point? Not spread across space, not diluted over planets, but concentrated, intensified, directed, at one exact location. What would happen? Would it create infinite energy, a planet-sized explosion, or something even more terrifying? Let's dive in. Point number 1. Before we go extreme, we need to understand just how powerful the sun really is. The sun releases about 3.8 multiplied by 10 raised to the power 26 watts of energy every second. To put that into perspective, that's a trillion nuclear bombs worth of energy. Every second. Earth only receives about 1/2 billionth of that energy. And even that tiny fraction is enough to drive global weather systems, power photosynthesis, sustain all life on Earth. Now imagine taking all of that energy and squeezing it into a single point, not spreading it across space, but focusing it like a cosmic laser. Point number 2. You might be wondering, is this even possible? Well, in theory, yes. We already use mirrors and lenses to concentrate sunlight. Solar furnaces on Earth can reach temperatures of over 3,000 degrees Celsius using just a small fraction of sunlight. Now scale that up to the entire sun. All that energy would then be aimed at one location. This would require a mega engineering structure, something like a Dyson Sphere or a massive array of mirrors surrounding the sun, capturing and redirecting its energy. All that energy would then be aimed at one location. Think of it as the ultimate magnifying glass, but instead of burning ants, it's burning reality itself. Point number 3. Let's talk temperature. If you focus the sun's entire energy output into a small area, the temperature wouldn't just increase, it would skyrocket beyond anything we can naturally experience. At the core of the sun, temperatures reach about 15 million degrees Celsius. But concentrated energy at a point? It could exceed that. Why? Because you're not just generating heat, you're compressing energy density to extreme levels. This could create temperatures high enough to vaporize any known material instantly, break atoms apart into subatomic particles, create plasma hotter than the sun itself. At this point, matter doesn't behave normally anymore. It becomes something else entirely. Point number 4. Instant vaporization. Let's say we focus all that energy onto Earth. What happens first? Everything at the impact point would be instantly vaporized. Not melted, not burned, gone. Oceans would flash into steam in milliseconds, land would turn into plasma. Atmosphere would ignite and expand violently. The energy release would create a shockwave so powerful, it would rip across the planet at unimaginable speeds. Within seconds, the entire surface of Earth would be destroyed. But it doesn't stop there. Point number 5. Planetary destruction. The energy involved isn't just enough to destroy cities or continents, it's enough to destroy the entire planet. Earth's gravitational binding energy, the energy required to completely break it apart, is about 2.2 multiplied by 10 to the power 32 joules. The sun outputs more than that, in just a few days. So if all solar energy were focused continuously at one point on Earth, the planet wouldn't just be scorched, it would be blown apart, ripped into fragments, turned into a cloud of molten debris orbiting the sun. In other words, Earth would cease to exist. Point number 6. Creating a black hole? Now here's where things get even more mind-blowing. Could this concentrated energy create a black hole? The answer is maybe. To form a black hole, you need to compress enough mass or energy into a very small space. This is described by Einstein's famous equation, E equals to mc squared. Energy and mass are interchangeable. If you concentrate enough energy into a tiny region, it can effectively behave like mass. If the energy density becomes high enough, it could theoretically collapse into a black hole. But here's the catch. You would need an absurd amount of energy focused into an incredibly small space, far smaller than anything we could realistically achieve. Still, with the entire sun's energy, we're entering territory where physics starts to blur. Point number 7. A beam that cuts through space. Instead of a stationary point, imagine directing all that energy into a beam, a focused solar beam traveling through space. This would be the ultimate cosmic weapon. It could slice through planets, vaporize asteroids instantly, even strip atmospheres from entire worlds. If aimed at a planet like Mars, it could potentially terraform it, or completely destroy it. If aimed at Jupiter, it might trigger massive atmospheric reactions. And if pointed at a star, it could disrupt stellar processes. This isn't just energy, it's control over matter at a cosmic scale. Point number 8. Impact on space itself. At extreme energy densities, something strange happens. You don't just affect matter, you start affecting spacetime itself. According to physics, massive energy concentrations can warp space and time. If all solar energy were focused tightly enough, it could create intense gravitational distortions, radiation bursts stronger than gamma-ray bursts, shock waves through the fabric of spacetime. This would no longer be just a physical event, it would be a cosmic phenomenon. Point number 9. Could we harness it? Now let's flip the scenario. Instead of destruction, could we use this energy? If controlled properly, focusing solar energy could provide unlimited clean energy, power for interstellar travel, the ability to move planets or build megastructures. A civilization capable of this would be considered a Type 2 civilization on the Kardashev Scale, able to harness the full power of its star. But the challenge isn't just capturing the energy, it's controlling it, because one mistake would mean instant annihilation. Point number 10. The ultimate risk. Here's the truth. Concentrating all solar energy into a single point is not just powerful, it's unstable. Energy at that scale is incredibly difficult to contain. Even the slightest misalignment could redirect the beam. And if that beam hits Earth, another planet, or even your own infrastructure, the result would be catastrophic. This is the kind of power that demands perfect precision, because there are no second chances. Point number 11. Real-world parallels. While this scenario is extreme, we're already taking small steps toward it. Scientists are developing solar concentrators, space-based solar power systems, laser energy transmission. These technologies aim to capture and focus sunlight more efficiently, but they operate at a tiny fraction of the sun's total output. We are still far from harnessing even 1% of solar energy, and maybe that's a good thing. So, what happens if all solar energy is focused at a single point? Temperatures beyond imagination, instant vaporization of matter, potential destruction of entire planets, possible creation of extreme cosmic phenomena. It's a reminder of something important. The universe is filled with unimaginable power, and we exist safely, because that power is spread out, balanced, controlled by the laws of physics. But if concentrated, even for a moment, it could rewrite reality itself. Don't forget to like and subscribe for more deep dives into space, physics, and the mind-blowing possibilities of the future. Thank you.